So, Kevin, have you ever heard of the photoelectric effect?
No, I haven't. Not outside of chemistry courses. What
Yeah.
is it?
So the photoelectric effect is basically a little miracle as far as I can tell. But the way that the photoelectric effect basically is that for every substance, if you shine light on it at a certain wavelength and with a certain energy, you can get an electron to bounce off of the substance. And every substance is different in terms of how much energy you have to put in that light that you put on it to make it generate kick off an electron. Now, I would bet that you might not have heard of the photoelectric effect, but I think that it should be plausible to you that it actually exists, because you know, and all of our students know, that when you shine light on a solar panel, there's a mechanism by which those electrons start moving away from the solar panel, and we use them for generating electricity. So that's not exactly the photoelectric effect, because the solar panels are made up of compounds, and there's different ways that those photovoltaic cells work. But the point is that you should at least have some inherent belief that when you shine light on things, you can get electrons to move. And that's what we're going to take advantage of today, to try to understand some things about atomic structure. So on this Word document, basically it is showing how something called photoelectron spectroscopy works. And basically what happens is, over here on the left-hand side, it's showing that there is some beam of light. It could be X-ray, it could be ultraviolet, depends on how much power it needs. But it will, if you shine that light at just the right energy on a substance, it'll hit an electron in the substance, and the electron will bounce off. That's what this diagram over here is showing.
So the X-rays and the ultraviolet is light?
Yeah, exactly. So it's just some beam of energy of a particular wavelength and frequency, a particular amount of energy, that if it hits the substance, an electron comes off. And in photoelectron spectroscopy, you can detect how much energy it took for that electron to be ejected. And so this electron that's colored red here there's a peak in the photoelectron spectrum at 11.5. And that basically says that removing that electron took 11.5 megajoules of energy. That's how much this light beam had to have in order for that electron to be removed. Okay?
Okay.
Other electrons take different amounts of energy. Like I've got this blue one on this other diagram down at the bottom. And so you hit the compound, or hit the element with the right amount of energy, that blue electron gets bumped off, and I think it says 0.9 megajoules per mole of energy is required to remove that one.
Yeah.
Okay? So what we're going to do is we're going to take a whole load of photoelectron spectroscopy data, and we're going to plot it.
Just a quick question going back to that diagram you had.
Yeah.
Is that
sure.
the same atom? Just different electrons?
In this case it is. I mean, it's just showing that we're going to remove electrons from all sorts of different places in the atom, right? So typically, any particular atom only ejects one electron, because now it's an ion, and so it has a different energy state. But we're gonna hit atoms with all sorts of different types of energy, and we're going to record how much energy it takes to remove different electrons. So to speak.
Okay.
Okay.
I get it.
Yeah. So everybody, including you and I, should have up a graph that looks like this. You'll see that yours and mine look the same, except that I hand wrote mine rather than having the printed copy. But basically, if you look along the bottom of this graph, you're going to see that we're going to look at the first 20 elements of the periodic table. So here is the photoelectron spectrum for hydrogen, okay?
Yep.
And to make it easier for you, on the graph, I've already put in where 1.3 megajoules per mole is, okay?
Mm-hmm.
And so there's the photoelectron spectrum for hydrogen. We know that hydrogen has one electron. And so what I'm going to do is take the one electron that I know about hydrogen. I know, oh, look, across the bottom, that peak, how the width of that peak stretches across halfway between 0 and 2, which tells us that there is one electron at 1.31 megajoules. Okay, so that's what that photoelectron spectrum tells us about hydrogen. All right, so I'm going to look at my graph over here. I'm going to find hydrogen down at the bottom, and I'm going to go up to 1.31 megajoules per mole, and I'm going to write the number 1 because I've got one electron in there. Okay, and you're supposed to do the same thing.
Yep.
Okay. Perfect. Okay. Now that was easy because I told you it was 1.31 and I put 1.31 on the graph. The next element, helium, is going to be a little harder. Okay. So if I look at helium, and I can probably zoom in here a little bit, the photoelectron spectrum for helium says that at 2.37 megajoules per mole, something happens. Okay, so now I want to go back to my graph over here, and I say, okay, I've got helium, and I've got at 2.37 megajoules per mole. So I got to come up here and figure out where in here is 2.37. Well, you'll notice that on the left-hand side, there are no units. So we've got to try to figure out where 2.37 would be. And if we look at some of these other numbers, it'll give us some idea. Here's 1.1, here's 2.8, here's 4.18, here's 2.9. So 2.37 should be somewhere near where my finger is now. So what I'm going to do is I'm going to come over here at 2.37, and I'm going to draw a line. And I'm going to write 2.37 underneath it. So 2.37, and how many electrons does helium have at 2.37?
Looking at the peak, it's a little bit taller than that last one.
Yeah.
So it looks, if you bring down the width and the height of the peak down to the number of electrons, it looks like 2.
It's a 2, exactly. So what you and I are both going to do is we're going to go back to that place where we had 2.37, and we're going to write a number 2 on top of it. Okay, because there's 2 electrons at that it records at being 2.37 megajoules per mole.
Yeah.
Okay?
Okay.
Do you want to ask a question about that at this point? Or should we move on to the next element?
Well, it seems like then there would be more electrons on the next one. So
okay,
maybe the next one would be 3.
Let's have a look. Here's lithium. Lithium has 2 peaks. One is at 0.52, and one is at 6.26. So I'm going to come at, so I found lithium at the bottom, and I got to find 0.52. So I'm going to come up here somewhere. Well, here's 0.9, here is 0.59, here's 0.06. So 0.52 must be right up near the top of this piece of paper. Something like that.
Mm-hmm.
And do you remember what the other one was?
It was 6 point something.
Yeah, 6.26. So now I'm going to go back to my back over here, 6.26. So I'm going to look on this graph. Here is 4.68. Here is 8.0. So 6.26 is probably somewhere just in the middle of those, right about here. .26. Okay, so we've got the lines showing the energy that we have. Now we need to put the electrons in there. So if you look at the graph for lithium, what do you see there in terms of at 0.52 and 6.26?
So at 0.52, the peak is smaller, and it doesn't go to 2, so it's probably 1.
Yeah.
1 electron. And then the other peak, the 6.26 peak, it looks like it goes up to 2 electrons.
Yeah, that's exactly what that shows us. So let's put those on our graph. So I bring this up here. So at 0.52, there's 1 electron. And at 6.26, there are 2 electrons.
Okay. So I went from 1 electron to 2 electrons. Then 1 plus 2 makes 3.
Yep, exactly. Yep. So those of us that are experienced chemists will say that will know that that is accounting for all of the electrons that are in those elements. People who are not so experienced chemists may not know the total number of electrons that are available in the atoms at this point, but it's nice and consistent so far. So let's go to the next element.
Okay.
So the next element, what does the graph for beryllium tell us?
It looks like the peaks are at 0.90 and 11.5 for energy.
Yeah.
And they both appear to be the same height. And so if you drag it down to the number of electrons, it looks like both of the peaks are at 2 electrons each.
Okay, so let's put that on our graph. So at 0.9, we had 2 electrons, and at 11.5, we had 2 electrons. Fortunately, that's one of the ones that was already in there for us, so we didn't have to draw that.
Yep. Looks good.
So the next element is boron.
There are 3 peaks now.
Yeah, 3 peaks. One at 0.8 megajoules, one at 1.36, and one at 19.3. So we'll write those ones in, and then we'll worry about the electrons here. So let's, so 0.8. Got to be right around here or so. What were the other 2 numbers we needed?
They were
1.36 and 19.3.
Yep.
So 1.3, we're on boron. And what was the other one we had?
19.3.
19.3. So I've got a 12 and I got a 34. So it's probably in here somewhere.
Yep.
Your graph and my graph won't look absolutely the same. They'll have the same, they're going to be close to being the same, but they're not going to be absolutely identical, because where you're making your estimations on where those values are and where I'm making them isn't exactly the same. 19.3.
Okay. So now we just need to find the number of electrons, right?
Yep, correct.
So then, if we're looking at the peak on the top, the 0.80, that looks to be 1 electron. So then we can write 1 down. And then the other 2 peaks look to have 2 electrons because they're the same height and they go down to 2. So then we can write 2 for the other ones.
So there's my 1 that I just put in while you were talking, and here's my 2 and my 2. So far, so good?
So far, so good.
All right. Let's move to the next element. Carbon it is. So I'll do this one. I've got 3 peaks, 1.09, 1.72, and 28.6. Okay, finding carbon here, and I've got to get to 1.09 for carbon. So 1.09 here is 136. I've got a 1.01 here, so I'm going to go about there for 1.09 for carbon. And then I've got another one at 1.72. Here is 2.08, so maybe just a little above that. Something like that. 1.72. And the other one was 28.6. So here's a 34 and a 19, so it better be right in between those somewhere. So let's go right about here. And that number was 28.6. So 28.6 megajoules per mole for that one.
Yep.
So that gets me carbon's amounts of energy. So now we just got to figure out how many electrons are in each one of them. So looking at that, I see 3 peaks. They're all the same height, and they stretch over to 2 electrons. So, and I'm going to come over here and I'm going to say there are 3 peaks, 1, 2, 3, and they each had 2 electrons. 2, 2, and 2.
Looks good.
Cool. Now, you and I keep on going at this same rate, working them like this. But if any of our students at this point have figured out how to are comfortable working their way through this, they should be able to open up the PowerPoint and just start marching through the rest of the slides and the rest of the elements until we get to calcium. So the next element is nitrogen.
Mm-hmm.
Nitrogen has 3 peaks at 1.4, 2.45, and 39.6. Yeah, so 3 peaks. So here's nitrogen, 3 peaks at 1.40. So 1.40 should be right around here, looks like. 1.40. 2.45. Well, it's going to be scrunched right in here. 2.45 and 39.6. We got some space down here for this one. So three peaks at those values, those energies.
Don't worry if it's too crowded too. It should be a little bit distinguishable, but mine is looking a little crowded.
Yeah. Okay. And they always are, and I have almost always my students have no problem being able to work with them afterwards because it works out pretty well. Okay. So here's nitrogen. So we had 3 peaks, 1.4, 2.45, and 39.6. And what do you notice that's different about this one?
That first peak, the 1.40 energy peak, goes all the way to 3 electrons, I believe.
Yeah, sure does. Sure does. So we've got in the first peak, we've got 3 electrons. In the second peak, we've got 2 electrons, and in the third peak, we've got 2 electrons. And so when we fill that in on our PES graph, we're going to match that. And so we find nitrogen, we go up to nitrogen. At 1.4, there was 3 electrons. At 2.45, there was 2 electrons, and 2 electrons at 39.6.
Yep, looks good.
Show me your graph. How's it look?
Let's see. Is there an easier?
Yep, it looks great.
The marks are about in the same place, so it looks like I'm doing all right.
Yeah, no, I think it'll work. Okay, so next element, oxygen.
We got 3 peaks again. I don't know if you have your, yep, you have your graph open or the energies for it. We have 3 peaks. The first one is 1.31, second one 3.12, and the third one at 52.6. So we just have to match those energies up again. So if we go back to the graph we're making.
What were those numbers again?
First one is 1.31. So that should be between 1.1, 1.40.
Yeah, something like that.
The second one is 3.12. So if you look all the way to the right, there's a 2.9. So it should be a little bit below that. 3.12. And the last one is all the way down at 52.6.
Here's a 40. I got a 42 over on the right, so it should be a little below that. Right?
Yep.
You said 52.6?
Yes, sir.
Okay, 52.6.
So those are our energies. Back at the energy graph, at the peaks, the top peak, the 1.31, is even further now. It goes all the way to 4 electrons. And then the other 2 peaks, the 3.12 and the 52.6, still go to 2. They're the exact same. They go to 2 each. So going back to the graph we're making, the 1.31 is 4. The 3.12 is 2 electrons. And so is the 52.6. 2 electrons there.
Next element, what are we on? Fluorine. We're halfway done. Okay, so we're on fluorine. All right, so there's fluorine. So 3 peaks again. So we're going to have 3 lines. 1.68, 3.88, and 67.2. We're on fluorine down here. So 1.68. There's a 1.72, so it better be just a hair above that. And then 3.88.
Yep.
And 67.2.
Correct.
Okay, read that graph for me.
All right. So if we look at the bottom 2 peaks, they both are the same again, and they both look like 2 electrons.
Yep.
And then the top peak, the 1.68 energy peak, is a little bit bigger than the last one. It doesn't go all the way to 6, but it's more than 4, so it should be 5 electrons for that one.
Yep. So let's put that one in there.
The first one is 5.
We're on fluorine, right?
Yes. And then the other two are 2 electrons each.
Okay.
All right.
So Kevin and I have made it through to the end of argon. Kevin, can you hold up yours so we can have a look at yours as well?
Yeah, no problem. Give me 1 second.
Sure, let me pin your video here. Okay. Yeah, looks great. Looks basically exactly the same as mine, right? I think. Do you agree that they both look pretty close to being the same?
Yep.
Okay, so we've got a couple more to do here. We just finished argon, and now we've got potassium.
Just a quick reminder too, the slideshow we currently were using doesn't have magnesium, Mg.
Right.
So we skipped over that one for now.
Yeah, yeah. But we'll make sure that we have that one. Okay, so potassium. I count 1, 2, 3, 4, 5, 6 peaks.
6 peaks, yep.
And I started to find it easier doing it from the bottom up. So 347, 37.1, 29.1.
3.93.
Yeah, 3.93 should be about, it's hard to tell all of these. 3.93. What were the last two?
2.38.
2.38 should be about here. And is there one more?
Yep, 0.42, so even higher.
Oh, right up at the very top. Yeah. So we might sneak a little bit out of here on my piece of paper and go like this. 0.42. And okay, let's go back to the graph and check those. Check how many electrons are in each place again.
Mm-hmm. So starting from the bottom,
Okay.
347 has 2 electrons. And so does the 37.1.
Okay, keep going.
The 29.1 goes all the way up to 6 electrons.
Yeah.
6. 3.93 goes up to 2. The 2.38 goes up to 6. And then finally, the top peak, the 0.42, only has 1 electron.
So this 2.38 represents 6 electrons, and the 0.42 only goes across to 1 electron, right?
Correct.
Okay. Cool. And so looks really promising right now, doesn't it? Okay, last one.
Yep.
Right. All right, guys. This one's given, isn't it?
Yep.
So 390, 42.7, 34, 4.65, 2.9, 0.59. And I read this as being 2 electrons, 2 electrons, 6 electrons, 2 electrons, 6 electrons, 2 electrons.
Yep. Got that too.
So 2 electrons, 2 electrons, 6 electrons, 2 electrons, 6 electrons, 2 electrons.
And with that, we're finished.
Right. Oh, just got a little skewed there.
Oh, except for magnesium. But
yeah. I filled in magnesium by looking on my own. But so that is all of the photoelectron spectroscopy data for the first 20 elements of the periodic table. And it tells us a lot about how many electrons there are in various locations and various orbitals. And we're going to come back in tomorrow, and we're going to look at this data and try to decipher some patterns and try to understand what it tells us about the various elements.
Mm-hmm.
How does that sound to you, Kevin?
Sounds like a plan.